quantities have a proportional relationship if the ratio of one quantity to the other is a constant. In a proportional relationship, the constant unit rate is called the constant of proportionality and is usually represented by K. Yes, in this class, we will be referring to the constant of proportionality using the variable K. Ratios can be written as fractions with a colon or with the word to. In order to find the constant, you must divide the dependent variable y by its corresponding independent variable x. Now let's take a look at page 18, which you guys worked on yesterday. For number 7, most of you selected table number 1. I believe that you were looking at the fact that the weight of the carrots were going up by 1 and the number of carrots were going up by 10. So most of you seen that happening. So you automatically assume that the table contained a proportional relationship. But as you can see in the book, the table that shows a proportional relationship is table number 2. So from now on, I want you to stop looking at the increase. And if you see the same saying that the table has a, constant increase in reference to table 1 is going up by 1, they're going up by 10. Don't automatically assume that there is a proportional relationship. In order to figure out if the table has a proportional relationship, I need you to divide. Divide and see if you get the same value each time. And if you do, that means the table has a proportional relationship. So for table 1, you have to divide 23 by 2, then 33 by 3, and 43 by 4. And if the value is the same each time, then that table contains a proportional relationship. If not, the table does not contain a proportional relationship. The same thing with table 2. You have to divide 23 by 2, 34 and 50 hundredths by 3, and 46 by 4. And each time you get the same quotient, then the table contains a proportional relationship. Well, let's take a look at the division. For table 1. The quotient of 23 and 2 is 11 and 5/10. And the quotient of 33 and 3 is 11. 11 and 5/10 and 11 are not the same. Therefore, that table does not contain a proportional relationship. So let's look over here. Table 2 has the ratio 23 to 2 to 23, and as well. So that was the first value for both tables. So remember, 23 divided by 2 is 11 and 5/10. And 34 and 50 hundredths divided by 3 is also 11 and 5/10. So 46 divided by 4 is also 11 and 5/10. Therefore, that table has a proportional relationship because each time you divide those values, those quantities with its corresponding value, you get the same quotient. All right, let's look down at number 8. Use the proportional relationship in the table. So from the beginning, it tells us that the table contains a proportional relationship. So in order to write your equation, you need to first find K. In order to find K, you have to divide, choose a set of values, and divide y by x. Remember, K is the constant of proportionality, and the way you find it is you divide y by x. So in this case, I chose the first set of values, and I divided 32 by 2, and I got 16. Therefore, K is equal to 16. All equations are written in the form y equals kx. If k is equal to 16, the equation will be y equals 16x. So the table then the question then asks you, what is the table going up by? The problem says write an equation, so that's what you needed to do. Some of you did not do that. You just said, you mentioned 16 in your answer, but you didn't go into details as far as writing the equation. Number 9, what is the meaning of the constant proportionality in this situation? For that problem, a lot of you just said, oh, it's going up by 24. That's all you said. But you have to talk about the meaning in reference to the situation. If you divide, each time you get 24. And that tells you it takes 24 hours to build each chair. Or if it takes 48 hours to build 2, you divide, you get 24. If it takes 72 hours to build 3 rocking chairs, you divide, you get 24. If it takes 5 hours to build 120 rocking chairs, you divide, you get 24. That means it takes 24 hours to build each chair. Alright, so it says describe a method for determining whether a table represents a proportional relationship. One possible answer could have been write and simplify the ratios of the outputs to the inputs in the table. If all the ratios are equivalent, the relationship is proportional. So output to input again is y divided by x. If you divide each time and you get the same value, that means the table has a proportional relationship.